students, today we are going to cover the topic from chemistry, thermodynamics. Before going to the topic, one thing I want to mention that you have to prepare yourself in a very structured way. So, you must know some basic things about joint entrance examination. The exam pattern you must know about the negative marking, the number divisions, important syllabus areas. Syllabus you already know, but the topics where you need to give the emphasis, that part you must know. Practice strategy, time management. You have to do practice with proper time management. Okay? And when you do so, you know your common mistake and you have to avoid those mistakes. Covering these parts, we have already posted some videos from our college. You must see those videos. Okay? Now, we are starting our topic, which is thermodynamics. Mainly we will do previous year questions, we will solve previous year questions, but when you will do so, you will get to know which part of thermodynamics are very important to understand and which part you have to make clear very well. Okay. Our first question from thermodynamics is, among the following the extensive variables are. You know that two type of variables, one is intensive variable, another is extensive variable. Intensive variable means mass independent properties or which does not depend on the amount of substance, and extensive properties depend on the amount of substances. Here the first one, extensive variables, that is depend on the amount of substances. Volume, volume you know, it depend on the amount of substance, volume depend on the amount of substance. So, this is extensive variable. Volume is extensive variable, depend on the amount of substance. Pressure does not depend on the amount of substance. So, this is intensive variable. Internal energy. What is internal energy? Every system has within itself some amount of energy, that is rotation, that may be rotational, vibrational, translational, electronic, etc. So, when amount of substance increases, internal energy also increases. So, it is also extensive variable. Enthalpy. Enthalpy H is equal to E plus PV. E is internal energy, which is extensive property. Pressure is intensive, but volume is extensive property. So, overall this property is also extensive property. Extensive plus extensive is overall extensive property. So, this is also extensive property. Moving to next question. Adiabatic free expansion of ideal gas must be. You can see the process is adiabatic and free expansion. Free expansion means expansion against zero pressure. Now, from first law of thermodynamics, we know that dq equal to dE minus dW. Minus sign we use to denote work done by the system, as it is expansion, it is work done by the system. Now, process is adiabatic, so dq is equal to 0. Free expansion, so P pressure is equal to 0, against 0 pressure the expansion occurs. When P is 0, P dV is equal to 0, and this P dV is the amount of work done minus dW. So, work done is also equal to 0. Therefore, dE is equal to 0. Remember one thing, dE for ideal gases is equal to CV dt. You must remember that dE equal to CV dt, which is equal to 0. Now, CV not equal to 0, therefore, dt is equal to 0. dt 0 means which process is this? This is isothermal process. So, the process must be isothermal. Okay. Our next question, X, capital X is an extensive property and small x is the intensive property of the thermodynamic system. Which of the following statement is correct? Okay. X, one is extensive property, this one is intensive and this one extensive. So, overall the property is mass dependent, as one property is mass dependent here. So, this is extensive property, right. B, x by x, that is intensive by extensive. So, the lower part is extensive. So, the overall will be, the process will be extensive property because one mass dependent property is there. So, this is intensive, this is not correct. C, x by x, that is extensive by intensive, the upper part is extensive property, that is mass dependent property. So, it is extensive property. And the last one, dx by dx, here same as C, here we are considering the small change, but it is again mass dependent. So, this is extensive, not intensive property. So, these two are correct statements. Next question, for a spontaneous process, the incorrect statement is, this is a very important part from thermodynamics. You must have the clear concept about this part. Spontaneous process. In term of energy, every system wants to attain the minimum energy, that is delta E is negative. Also, in term of entropy, system want to attain maximum randomness, that is delta S should be positive for spontaneous process. These two are in term of energy and entropy. But some processes are there where the process is spontaneous, but energy increases, that is delta E may be positive also. Similarly, delta S may be negative also. Some spontaneous process are there where entropy decreases. That is why another term which is delta G, G is gives free energy, G is equal to H minus Ts. This ultimately define the spontaneity of any process, where both energy factor and randomness factor are there, and delta G is always negative for spontaneous process. So, in general, for any spontaneous process, if it is in general process, then you should consider delta E negative, delta S positive, and delta G is always negative, always negative. So, here incorrect statement is this one only. Next question. An ideal gas expands adiabatically against vacuum. Which of the following is correct for the given process? First, the process is adiabatic. From first law, we know dq equal to dE minus dW. As process is adiabatic, dq is equal to 0. Internal energy sometimes we write as E and sometimes as U. Here U written, so we can write U also as U written in the question. I am writing as U. Acha. Expansion occur against 0 pressure. So, work done is equal to P dV, which is equal to 0. So, this is also equal to 0. Therefore, du internal energy change is also equal to 0. Internal energy change is equal to 0. What about delta T? Delta T, when du 0, we know du equal to Cv dt is equal to 0. So, Cv not equal to 0. So, dt equal to 0. So, this is wrong, delta T negative, this is wrong. Delta S, as the process is expansion, entropy always increases. So, delta S is greater than 0 for this process. Now, delta P, as the gas expand, pressure decreases. So, delta P is negative, less than 0. So, only correct statement is delta U equal to 0. Next question. For spontaneous polymerization, which of the following is or are correct? First one is delta G is negative. I have already told you that delta G is always negative for spontaneous process. So, this one is correct. What about delta H? Delta H is enthalpy change. As the process is polymerization process, monomer combine to give polymer. So, the system gets stabilized and release energy. So, the process is exothermic process where delta H is negative. So, this one is also correct. What about delta S? Monomer combine to give polymer. So, randomness decreases. Here delta S is not positive, here delta S is negative, randomness decreases, and delta S negative, this is correct, delta S is negative for the process. Moving to next question. If you not understand anything, you can write in the comment box, we will try to solve those problems. Next question is, for the equilibrium H2O liquid to H2O vapor, which of the following is correct? This is an equilibrium process. For equilibrium process, delta G is 0. Remember that for spontaneous it is negative, but at equilibrium delta G is 0. So, this may be correct or this. Between A and D, you can see the enthalpy and entropy. Here for enthalpy and entropy we will consider the forward reaction. Here liquid to vapor means energy required to break the bond. When liquid form vapor, energy needed to break the bonds. So, delta H is positive, endothermic process. So, delta H should be positive, and also liquid form vapor. So, randomness increases, delta S is also positive. So, D is correct. Next question. At constant pressure, the heat of formation of a compound is not depend on temperature when at constant pressure heat of formation, that is we are considering Cp. What is heat of formation? Heat required to increase temperature 1 degree centigrade of 1 gram of substances. That is, you can say heat of formation is dQ dt and it occur at constant pressure. Cp equal to del Q del T P. Now, when it does not depend on temperature, the delta Cp becomes 0. So, this option is correct. Next question, which of the following is true in respect of adsorption? Again, it is, as adsorption is spontaneous process, so delta G should be negative. Delta G is less than 0. It is adsorption, so after adsorption randomness decreases, so delta S should be negative, and delta H, again after adsorption bond gets stabilized, so it release energy and the process is exothermic, that is delta H is negative, less than 0. So, option B is right. Next question, during a reversible adiabatic process, the pressure of a gas is found to be proportional to the cube of its absolute temperature. The ratio of Cp and Cv of the gas. Ratio of Cp and Cv, Cp by Cv is gamma. Again, here pressure is found to be proportional to cube of absolute temperature. The process is reversible adiabatic process. You must remember, for reversible adiabatic process, pressure volume relation is P V to the power gamma equal to constant T V to the power gamma minus 1 is equal to constant. This is temperature volume relation, this is pressure volume relation, and pressure temperature relation is T to the power gamma P to the power 1 minus gamma is equal to constant. Now, here we need this relation where T to the power gamma P to the power 1 minus gamma equal to constant. Also, we can write this equation as T to the power gamma is proportional to 1 by P to the power 1 minus gamma, or T to the power gamma is proportional to P to the power gamma minus 1. And if we put this, we will get, in place of P, we are writing T cube and gamma minus 1, that is T to the power 3 gamma minus 3. Therefore, from this we can write gamma is equal to 3 gamma minus 3, or 3 gamma minus gamma is equal to 3, or gamma from this is equal to 3 by 2. So, this is the correct answer. Gamma is equal to 3 by 2. Next question. Given below are two statements. Statement 1, when a system containing ice in equilibrium with water is heated, heat is absorbed by the system and there is no change of temperature of the system until the whole ice get melt. This is correct. The statement 1 is correct. There is no change in temperature until the whole ice get melted. Statement 2, at melting point of ice there is absorption of heat in order to overcome the intermolecular forces of attraction within the molecules of water in ice, and kinetic energy of molecule is increased at melting point. This is also correct statement. The heat required is used up to break the bond only. So, both are correct statement. Both statement 1 and statement 2 are correct. Option C. C is correct. Next question. Two vessels A and B are connected via a stopcock. The vessel A is filled with a gas at a certain pressure. The entire assembly is immersed in water and is allowed to come to thermal equilibrium with water. After opening the stopcock, the gas from vessel A expands into vessel B and no change in temperature observed in the thermometer. Which of the following statement is true? As no temperature change occurred, you can say dT is equal to 0, process is isothermal. Also you can say Cv dt is also equal to 0 as dt 0, because Cv not equal to 0 and Cv dt is equal to du. So, du is equal to 0. As no temperature change occur, so no heat change with the surrounding. So, dq also should be 0. When dq and du both are 0, from first law dq equal to du minus dw, where dq 0 and du 0, you can say dw is also equal to 0. So, work done dw is also equal to 0. Now, when dw is 0, dw equal to pdv, dw is equal to pdv. dv not equal to 0, because initial volume was V1 was volume of A and V2 is volume of A plus volume of B. So, dV not equal to 0. Therefore, we can say expansion occur against 0 pressure. Pressure is equal to 0. The pressure in vessel B before opening the stopcock is 0. This is correct statement or true statement. Next question. 1 mole of an ideal monoatomic gas is compressed adiabatically from volume 2V to V. So, we can write initial volume V1 is equal to 2V and final volume V2 is equal to V. If the initial temperature of the gas is T, so initial temperature T1 is equal to T, then the magnitude of work done in the process. How we get work done? Work done for adiabatic process. We know From first law, dq equal to dE minus dW. Now, as the process is adiabatic process, dq is equal to 0. So, we can say dW is equal to dE. Here compression occur, so we will not take the negative sign, we will take dW which is equal to dE, and we also know this is equal to CV dt. So, total work done, what will be the total work done? CV dt. Total work done will be at CV is constant, W is equal to CV from the temperature change T1 to T2, initial to final temperature CV T2 minus T1. This is the expression of work done. Here we know the value of T1 which is equal to T, but we do not know T2. We have to find out T2 in this expression. For adiabatic reversible process, the relation between temperature and volume is T1 V1 to the power gamma minus 1 is equal to T2 V to the power gamma minus 1. Now, T1 is equal to T here, V1 is equal to 2V to the power gamma minus 1, T2 we do not know, V2 is V to the power gamma minus 1. So, if we solve this, we will get, or T2 equal to 2 to the power gamma minus 1, V to the power gamma minus 1 and T divided by V to the power gamma minus 1. These two will cancel out, and T2 we are getting as 2 to the power gamma minus 1 into T. Now, this is a monoatomic gas. For monoatomic gas, we know CV equal to 3 by 2 R and Cp equal to 5 by 2 R, and Cp by Cv which is equal to gamma. I am removing this part. I am removing this part. Cp and Cv, gamma which is equal to Cp by Cv which is equal to 5 by 2 R divided by 3 by 2 R, that is 5 by 3. Now, I am going to the expression of work done which is equal to Cv T2 minus T1. Put the values, Cv equal to 3 by 2 R, T2 equal to, we got 2 to the power gamma minus 1 into T, and T1 is equal to T. Put the value of gamma also, 3 by 2 R, I am taking out T outside, gamma is equal to 5 by 3 minus 1 minus 1. So, ultimately we get the expression of work done RT 2 to the power 2 by 3 minus 1. So, you can see this is exactly this equation. Okay. Moving to next question. This is a mixed type of question. Here thermodynamics is also there, some other part is also there. Achha. Identify the correct statement. The oxidation number of Cr in CrO5 is +6. CrO5, that is Cr, this is the structure of CrO5. You can see oxidation number of chromium, suppose X, this O having -1, -1 each, and 4 for 4O, this is -1 into 4, and for this O, double bonded O, it is -2 into 1 is equal to 0, or X is equal to +6. You can see -4, -2, -6, and it goes there, and this become +6. So, this is correct statement. Next statement for this equation, this is from thermodynamics, this option, delta H greater than delta U. We know that delta H is equal to delta U plus delta N RT. Delta N for this process you can see 2 minus 1, that is 1. Delta N is equal to 1. Delta U is positive here because N2O4 breaks into NO2. As it breaks into NO2, to break the bond it needs energy. So, delta U is positive. This part is also positive. So, you can see delta H here is greater than delta U. This is also a true statement. pH of 0.1 normal H2SO4 and pH of 0.1 normal HCl. Both are strong acids and both having same concentration. But here you can see 2 H plus present in H2SO4 and here 1 H plus. As the number of H plus increases, pH decreases. So, pH of H2SO4 is less than pH of HCl. Last option, RT by F equal to this. This one is wrong because we know that 2.303 RT by F is equal to 0.0591 volt. So, this is incorrect statement. Today up to this, if you have any doubt regarding any question, you can write it in our comment section. We will try to solve those problems. Okay? Thank you.